Reflection is a mirror image about a line or axis. Invariant points are points that do not move after a transformation. So this is the key thing here. Invariant points are points that do not move after a transformation. They'll ask you for invariant points. I'll ask you for invariant points. So if a point moves and lands on top of a point that was originally there, that's not invariant. Invariant is, here was my point originally. After I do all of my stuff, my point's still there. So that point did not move. Not a point moved and landed on top of it, right? It's the point that was there, we transformed, we used our mapping, all of our points moved except for that one. It stayed the same, then it remains invariant. Okay? So we're going to deal with reflections in the x-axis first, which you actually did reflections in the y last year. Reflections in the x, you can have y equals f of x equals y equals negative f of x, or negative y equals f of x. So if you could move that negative with the y, it actually reflects in the x. Well, why is that? Let's think about mapping. If it's in the bracket with the x, it affects the x variables, right? So if it was with the x and it was x minus 4, then we moved 4 to the right. And we went x plus 4, right? That's what we did. Anything in the bracket with the x affects the x variable in mapping. Anything not in the bracket with the x affects the y variable in mapping. Very important. So if it's with the x in the bracket of the equation, it affects the x in horizontal translations, all that stuff, but it also affects the x in mapping. If it's not in those brackets or with the x, then it affects the y. Okay? So this here technically is affecting my y, isn't it? Because it's with my y. We agree? Even if it's over here, it's still not with my x, so it's with my y. We agree? So my mapping would be xy becomes x negative y, doesn't it? We agree? Because it's with the y, it affects the y's in mapping. So I'm not going to do this right now. I'm just going to show you, don't draw on this because we're going to show you something else, but I'm going to put that one on. But for just now, don't draw this because it's not going to stay on here. Say I had this coordinate on here. Don't draw it. It's not going to stay on here. So 1, 2, 3, 4, negative 5, and 3. We agree? So if we have negative 5 and 3, and I plug that into my mapping, which I just said, xy becomes x negative y. I'm going to get negative 5, 3 becomes negative 5, negative 3, doesn't it? Which happens to make it go down here. What axis am I reflecting on? The x. So when it affects the y's, it's actually reflecting on the x, isn't it? Because it's taking the positive y's and moving them below the x-axis, and the negative y's moving them above the x-axis. And what axis is it reflecting on? It's reflecting on the x. It's above and below, right? So whenever it's a negative y, it actually is a reflection in the x-axis, which makes sense. You have to make it make sense. If you're just memorizing, that scares me. Because memorizing, you could go, oh, crud, is it x or y? I can't remember. We don't want you to memorize. I want you to understand why it is, and then you never get it wrong. Because if you understand why, you're not going to accidentally be like, is it x or y? Okay, if it affects the y's, if my y is up here, it's now down here. If my y is down here, it's now up here. And the axis I'm reflecting about is that x one. Right? So, oh, it's a reflection about the x-axis. I want you to understand, not memorize. And memorizing scares me. Okay? So we know that it'll be a reflection in the x. Now, the graph of y equals this is shown. Well, it's not. We're going to show it. So we're going to type that into our calculator. X squared minus 4x plus 4. And then you're going to go second graph to your table of values and pull some points off of it. I don't remember what it was. X squared minus 4x plus 4 or plus 4x plus 4? Minus 4x? There it is. Remember, if we wanted to find the minimum, the vertex, in this case it's a minimum, right? It looks like it's on the x-axis, but let's find it anyways. We're going back. We're remembering what we did last year. So we're going to go second, trace. Our vertex is a minimum, so we're going to pick number 3. And we need to be on the left-hand side of it. Enter. Right-hand side somewhere, because it says right bound. Enter. Enter. So it's at 1.9999, which we can round to 2. And then this one will say 1.4. People will say, my y is 1.4, because they'll not see the e to the negative 12. E to the negative 12 is just scientific notation. So what this is it's 0 decimal 11 zeros 1 4. What can we round that to? 0. So whenever you see this e to the negative something, that's just 0. So please pay close attention so you don't write down 2 and 1.4 as the coordinate, which people will do, because they'll not spot the e to the negative 12, which is just 0. Okay? So this one's at 2 and 0. So I'm at 2 and 0. Then I can go second graph, and I find 2, 0. That's my vertex. And I take points on both sides of it, right? Work my way out. So I have 1, 1, 3, 1, 0, 4, 4, 4. So I'm going to plot those. One, 1, 3, 1, 0, 4, 4, 4. And I draw the full parabola. It's a quadratic, right? Yep. Second graph. So in grade 10, you were taught to make t-tables, right? So that you could get input, output. The calculator does it for you in the second graph. All right. Now it says write an equation that represents that. Okay. This is negative f of x. So I need to negate my f of x. We agree? So I'm going to go to my equation. I'll just do it here. So I'm going to go f of x. This is my equation. X squared minus 4x plus 4. We agree? They want me to negate my f of x. So I'm going to go negative f of x equals x squared minus 4x plus 4. Would I leave it like that, though? No, and I can't type it in my calculator unless it's f of x, right? F of x is just y input. So I actually have to get that negative 1 over. How do I move it over? Divide every term by negative 1. And that's where the error lies. People don't distribute it through. So I'm going to get f of x equals negative x squared plus 4x minus 4. Which is good, because I need the quadratic to be going downwards if it's a reflection in the x, right? I need to literally mirror down. So I have negative x squared plus 4x minus 4. Now, if you have a calculator that doesn't have colors, like mine does, mine has colors, yours may not, what you can do is, this is what I always do, so I can tell which one's which. I arrow over here. Nope, I'm arrowing down by accident. I arrow over here, and you'll just have a slash if you don't have a color, right? If you hit enter once, it makes a thicker slash. Now press graph. So it'll show you that the thin graph is actually the y1, and the thick graph is y2. Because when you press graph, they draw them in order, right? They draw the y1, then they draw the y2. But then you go to do some math, and you come back, and you're like, uh-oh, which one was y1, which one was y2? Well, you'll always know that if you make the second one thicker, the second one is your y2 equation. So you can go over to here, and you just hit enter once, and it makes the line thicker. And then you press graph. When you go back and you say you clear that equation out, it'll reset it back to the thin line. If you press it a whole bunch of times, which some of you will spend 10 minutes trying to figure out what things you could press to see what else there is, there's like dashed lines, dotted lines, things that don't help. There's shades, there's not shades, there's inequality. Nah, don't need any of that. Literally just want the second one if you don't have colors. Now, because I have colors, I know the blue is y1 and the red is y2. Okay? Do they look like they're reflected perfectly on the x-axis, that the x-axis is a mirror? As kids, did you ever stick your toothbrush up against a mirror or a hairbrush or something and see it reflect? So it's just me. Ah, I have a couple. Okay, good. If you just stuck your toothbrush or something against it, it reflects perfectly back to you, right? And your mirror is the actual mirror, right? Same thing here. If I stuck this parabola against this mirror, the red would be like into the mirror. It would reflect perfectly on itself, right? So if that happens, then you have a reflection in the x-axis, which is perfect because we actually do. Okay. So what could we do? We don't even need the table. What's happening? All my x's are staying the same and my y's are being negated, correct? So this one is 2, 0. It's becoming 2, negative 0. Is there such a thing? No, it stays the same. Oh, it stays the same. Let's keep that in mind. Then I have negative 1, 1. It's going to become negative 1, negative 1. Then I have 1 and 1. It's going to become 1 and negative 1 because of my mapping, right? I'm just carrying my mapping down. 4 is 0, 4. It becomes 0, negative 4. And this is going to become 4, negative 4. And I have a perfect reflection. We agree? So we have to remember what we do when we get a reflection in the x-axis. When we get a reflection in the x-axis, our y becomes negative in our mapping, right? Why do we need to know that? Because we're going to add stretches tomorrow, and then on Thursday, we're going to have everything together. And if we don't know all of our little pieces really, really well, when we put them all together, it's super overwhelming and you screw up. Okay? So to keep up with your homework, make sure you know your stuff backwards and forwards, or Thursday will be a mess, and I don't want it to be a mess. I want it to be like, ah, they all come together. I know what I'm doing. This is perfectly fine. I'm a genius. No big deal. Okay? This unit only has 4 lessons. It has transformations, stretches, reflections, inverses. That's it. Okay? But it's still a lot to do, even though it's only 4 lessons. What's my invariant point? What's the one that stayed the same? 2, 0. And it legitimately stayed the same. It wasn't like another point got laid on top of it. It's still there. It just did not change. Why did it not change? Because it was on the reflection. When you reflect, if you haven't done this, try it. Your toothbrush is at home. When you put your toothbrush against the mirror, what's the only thing that doesn't reflect? Piece against the mirror, right? It literally can't. It's on the mirror. So you wouldn't be able to see it. It's stuck there, right? Same thing here. If this is my mirror, my invariant point is going to be what's on that mirror. Because my y's are 0 there. And if my y's are 0 there and I negate a 0, it stays 0. That's why. So how does the graph of negative f of x compare to the graph of f of x? It's a reflection in the what? In the x-axis. Or you can say reflection about the x-axis. And I'm pretty sure the textbook says about. I can't remember every year. The textbook's the approved resource for it. Another reflection. It says in the textbook. But I know they accept in and they accept about. They don't accept around, through, or some of the weird ones. On, in, in, across, they don't. They could, and it would depend on the question, and that scares me, so I would just stick with in or about. Okay? I know they're both good. Okay, so this one, I have the negative. Is it with my x? Is it in that bracket? No, so in mapping it will affect my y. So I'm going to get xy becomes x negative y. If I only have a reflection, where is this invariant? This is a reflection on the, or a reflection in the x-axis, or a reflection about the x-axis, right? So where is it reflecting about? The x-axis. So where are my invariants going to be? The x-axis. So I'm going to draw them right away. Boom, boom. I don't even need to show anything. Those babies are staying the same. Right? They're not changing. Why are they not changing? Because their y values are 0. And if I plug them into mapping, I'll do it for you, show you one of them. 1, 0 is going to become 1, negative 0, which is 1, 0, right? Like it doesn't change. Okay? This one is at negative 2 and, nope, negative 1, try again, and 4. It's going to be at negative 1 and negative 4. Drew it. Could I use way more points to make it more accurate than 3? Yes. So if it was a unit test, I would use every coordinate that actually went through like an intersection. Okay, what do you think about this one? Oh, it's a negative with the x. So in mapping, I'm going to get xy becomes negative xy. Because it's with my x. And if it's with my x, it affects my x variable in mapping. Right? It affects all the x coordinates. Now the last one had a negative with the f of x, so I put a negative in front of the f of x and applied it, correct? This one is a negative in the brackets. Now, we're going back to grade 10. Weird. I keep saying that every single day, like 2 or 3 times. Well, I was telling you, grade 10 is important. I wasn't joking. It legitimately comes back up. It's like the basis of everything. Okay? So in grade 10, you were given this, and you didn't even know why you were given it, but you were given like f of x equals x plus 4. And then they would go f of 3. And what did you do? You put 3 in for the x, so then it went in for the x's, right? So you'd go 3 plus 4, and you tell me it was 7. And then your teacher was like, now I'm going to give you something awful hard. It's going to be crazy. It's going to be awesome, but it's going to be crazy. Ready? F of A. What did you have to do then? If you put 3 in for the x's, you're now just going to put A in for the x's. So we're going to get A plus 4. Crazy. Okay, now I'm in grade 12 and I'm like, trumping that one. You drop the mic after this one. This is like solidifying grade 10, all up in that grade 10 space. You're like, I don't know why we're learning this, but we're going to learn it. F of negative x, what would I do? Negative x plus 4. I'm just putting negative x in for the x's. Do you agree? Okay, full circle. What are they telling us to do? Put negative x in for the x's. So this is my equation. I'm going to get f of x. Now, do I need to write negative x? No, because I'm filling it in for the x's. It's going to get me negative x squared minus 4 times negative x plus 4. So I'm going to get x squared plus 4x plus 4. And now this better reflect on my y, right? So I can regraph x squared minus 4x plus 4. It was here. And when I sketch 2 graphs, I really should label the graph. And if they're both f of x, I have to write out the whole equation, right? Because I can't say this one's f of x and this one's f of x. Which one is the f of x I did? So that's why when you use f of x and g of x, it's easier because you can just go f of x and g of x. But if they're both f of x's, you have to list the whole thing. Yeah?
Would you like f of x and then f negative x?
No, because you technically would still have to call it an f of x in the end. Okay. Just because they would call it as a transformed function. Because this would be technically y and y, not even f of x, right? And then, which one's going to remain invariant this time? Yeah. The one on the y-axis, because that's my mirror now, right? Boom. That baby's staying. And then these are all going to reflect on the y. So this is going to come over here. This is going to come over here. This is going to come over here. This is going to come way over here. If you're like, dude, where'd you get all those points from? I just negated the x's this time. But if it's not for you, go like this. xy becomes negative xy. So I'm going to get 0, 4 becomes negative 0, 4, which is not actually true. So that's just a plus. So it stayed the same. 1, 1 becomes negative 1, 1, which I did. 2, 0 becomes negative 2, 0. 3, 1 becomes negative 3, 1. And then 4, 4 becomes negative 4, 4. So I just use my mapping, right? And I can get everything perfectly. Could I do this without mapping? Yes, because it's only one negative, right? But what if I have transformations and mapping and some stretches in there? Transformations and reflections and some stretching in there. I said mapping in there. I don't know. State the coordinates of the invariant point. It's at 0, 4. And what's actually 0 is the x, which makes sense. Because we negated 0, it stays 0. How does the graph compare? It's a reflection in the y-axis. Or a reflection about the y-axis. So this one, what's my immediate one that's not going to change my invariant point for this graph? 0, 2, the one on the y-axis. And everything's going to reflect on the y. So this one's at negative 1 and 4. It's now going to be at positive 1 and 4. This is at 1 and 0. It's now going to be at negative 1 and 0. This one's at 1, 2, 3, 4. Negative 4 and 0. It's going to be at positive 4 and 0. Okay? People who understand this unit do really, really well. The people who attempt to memorize this unit do not very well. That's bad English right there. They do about as good as that English sentence. It's bad. Because if you only know your stuff, even 95%, and say you flip your negative, put it on the wrong one the whole time, your mark's going to be like total crap. That's what it's going to be. So you need to know your stuff backwards and forwards. I'm not joking. I say this every year. People don't trust me. If you don't know it backwards and forwards, when it's negative x, it goes with the x on mapping, which means reflection in the y. If that can't come out of your mouth immediately and you're thinking and humming and hawing, the test will not be pretty. Because you're going to make those mistakes. And do you think they're going to have the answer to the common mistakes? Do you think I'm going to? Yeah, totally going to. Because that's how you do the answers. Yeah. Okay, so I want you to sketch this one, which is negative. It's a reflection in the what? X-axis, which means it makes the what negatives? Y's. Okay, sketch it. Go. So what's going to remain invariant for this one? Anything on the x-axis, right? Because my y's are 0. So people will do that and they'll tell me there's 2 invariants when there's actually 3 invariants. You guys fall to just the bubble ones. This one's invariant as well. It's on the x-axis, isn't it? There are 3 invariants for this one. And then these reflect to the y. 1, 2, 3, 4, 5, 6. 6. 1, 2, 3. And then this one comes here. So does that look like a reflection on the x-axis? Yep. It does. Then we'll do this one in blue. What's going to remain invariant for that one? Anything on the y-axis, because that's where it reflects. So if I start here, this one's 1, 2, 3, 4, 5, 6. So it's going to be xy becomes negative xy, right? So this is at 1, 2, 3, 4, 5, negative 6 and 0. It's going to be at positive 6 and 0. And I'm going to go to my next one. It's at negative 4 and 1, 2, 6. It's going to be at positive 4 and 6. And then I'm going to connect them so I don't mess up. This one's at positive 1 or negative 1 and 6. Now it's going to be at positive 1 and 6. This one's at 1, 2, 3, 4 and 3. It's now going to be at negative 4 and 3. Something is wrong. What did I do? Oh, negative 3. Up. It's at positive 4 and negative 3. It's going to be at negative 4 and negative 3. And then this one's at 7, 0, so it's going to be at negative 7, 0. So would I suggest you freehanding it like that, or would I suggest you mapping each coordinate and getting it correct? Map each coordinate and get it correct. The way that I just did that, I even made a mistake, but I thought that I had to go straight through it, but who knows? Especially if you have a whole bunch of things, like stretches, reflections, and translation, you're not going to catch them in Newsy. Okay? So, always use mapping. Okay. The graph drawn in the thick line is a reflection of the graph drawn in the thin line. So the thin line's original. Write the equation. So these should be labeled. This should be f of x. Both of these. How can we tell this one? Yeah. Invariant points, exactly. Where is it invariant? On the x-axis. So what's actually negative? Y, right? Reflections are always about the opposite axis of what it actually affects, right? So to affect the y, it's going to be about the x. To affect the x, it's going to be about the y. So this is on the x-axis. So this equation is actually going to be, sorry, this is y equals f of x. This one's going to be y equals negative f of x. It's with the y, right? This one's y equals f of x. This one is invariant on the y-axis. So that means it reflects in the reflects in the y-axis, but it affects the axis. You try example 7. So for this one, it's a reflection in the reflection in the y-axis, I don't know if that was what I said, but we're going to go with it. It affects the what? The x. So we're going to get y equals 10 to the negative x. And in our mapping, xy becomes negative xy. This one's a reflection in the x-axis. So it actually affects my y. So I'm going to put it over here. If you put it over there, it'll be fine. I'm going to get it there in a second. So I'm going to put it with my y because it affects my y. And then I'm going to divide negative 1 over. I would suggest you always do this because it needs to affect all the terms over here. So I'm going to get y equals negative square root x. So in the end, you may have gotten that anyways. But when it's a more complex equation, the negative has to affect all of the terms. And my mapping would be xy becomes x negative y. I know it didn't ask for mapping, but we can always make sure we know that too. I'm going to get you to do 9 and 10. So this one is negative f of x. So that means my y has to be negated, right? So I'm going to get negative y equals square root x minus 2. And I'll show you why in the next one if you didn't do this, why it's going to get you. 5 by negative 1 and y equals negative square root x minus 2. My mapping, just for extra showing you, the y is going to be negated, right? And what is this? This is a reflection in the what? X-axis, because it affects the y. Exactly. This one, I'm going to put negative in for my x. I'm going to get y equals square root negative x minus 2. It doesn't change the minus 2. You just take the x out, huck it behind your head, and replace it with a negative x, right? It doesn't affect that negative 2. If I have to do mapping, it'd be xy becomes negative xy. And that's a reflection in the what axis? Y-axis. Okay, this one's a reflection in the y, so it affects my x. Watch what happens. Nothing. Nothing happens. What the heck? It's the same question. Let's see why. So if I go x squared plus 1, right? It's symmetrical about the y-axis, isn't it? So it's going to completely flip-flop on top of it. So it's going to look the exact same. Did that mean that it actually stayed the same the whole time? No. The only point that actually stays the same is 0, 1, right? The other ones flip-flop on top of each other. You get the exact same equation, but they're not actually exact same. They did flip, okay? Because if I go put this one in, I get blue and I get red on top, right? So if you use thin and thick, then you can actually tell if it's the same. So it's a thin line and then the thick gets drawn over top of it, right? If you use thin and thin, you have a thin line and then you're like, yeah, I drew on top of it, when it could actually be like off in space over here and you just don't actually know it. You just assumed you drew it on top. So that's why I like the thin and the thick, so you physically see the thick get drawn on top of the thin one. Okay. And then the last one, a reflection in the x-axis, means I'm going to get a negative y. So some people will just say negative x squared plus 1, but it's actually not that. Divide by negative 1, divide by negative 1, divide by negative 1, and it's y equals x negative. If you want to put the x in brackets, you can. X squared minus 1. If you don't, if you just go negative x squared, it's the same thing. Remember? If I just do this, is that negative with the x? No, because it's not in the bracket with it, right? So I don't actually have to put the bracket, just some people like putting it so they see that it's not with it. And you should always check these. You can type this one in, x squared plus 1, and then you can type the other one in. Say you screwed up and you went negative x squared plus 1. Let's see. Is that a reflection in the x-axis? No, it reflects on itself, but it's not a reflection in the x-axis. So then I go back and go, oh, I did make a mistake. I'm wrong. I put the negative in. Is that a reflection in the x-axis? Yes. So you can catch yourself. Remember, you can type them in every single time as long as they don't have an f in the equation. Like if it's like f x plus 2 plus 1, then you can't type that in. But these are all like x squared. You can type that in. Totally fine. The square root one, you can type that in. Okay? And your homework is below. Yep. Didn't press that. What am I doing? Did you Google Classroom for a second? Okay? There's your homework.